Good afternoon, students. Let's start with the class. Today we'll start with a new chapter, differential equation. Earlier it used to be for 6 marks, but this time we have kept it for 7 marks. It will be this combination of both derivatives as well as integration. We'll start with the basic definition. I'll be using the shortcut, that is DE, differential equation. It is an equation involving one independent. I'll explain this. You just write first. Differential equation, it is one equation which involves one independent variable and one or more dependent variables and some differential coefficients. Now, what is this independent and dependent thing? So, suppose once we are differentiated, we used to get normally dy by dx. So, this is called as a dependent variable, and this is independent variable. So, we can form various types of equations involving dy by dx in this. Example. So basically it involves dy by dx term, x term and the y term. It could be any power, 2 times differentiated, 3 times differentiated, doesn't matter. And along with the differential coefficients. These are called as a differential coefficient. Nothing, this no questions will be asked what is a dependent, what is independent, just because it is there in the definition given. Otherwise, not necessary you have to know this. Now the next what I'm going to start from there onwards, actually you have to know for exam point of view. Anything of this form, okay, is called as a differential equation, which involves derivatives. Differential means you know that derivatives. So equation which involves derivatives are called as differential equations. What is important now is the order and degree. So first, what is the order? Order of differential equation is order of highest order derivative term appearing on it. Basically, for your reference point of view, highest time or maximum times, you can say maximum time derivative. How many times you can differentiate maximum number of time which is there in that equation, that becomes the order. Example, how many times you think this one has been differentiated? How many times has been the function differentiated? Yes, two times. Because of this, two. One, see, whenever it is y, this is a function given. Then first time when you differentiate, you get dy by dx. The order is one. When you differentiate it two times, so we will get like this. So looking at the maximum time which it has been differentiated, so that becomes the order is 2 now. Same way, suppose d raised to 5 y upon d x 5. So this order will be 5. So how many times, whichever the number appearing on it, will be the order. Now what is the degree? Degree of a differential equation. It is the power of highest order derivative. Power of the highest order derivative. After removing radicals. Radicals means root signs and fractions involving derivatives. Write this, then I'll explain. It is the power of the highest order derivative. So this is what you have to know. I'll give an example. Suppose if we have a differential equation, now this is a differential equation. I want to know what is the order of this equation and what is the degree of this equation. Now order means, I told you, check the maximum, the highest number which it has been differentiated to. So what do you think the order will be? There are two derivatives. One is dy by dx. The other one is dqy upon dx cube. Among this, what do you think the order is? The maximum one or the highest one? What will be the order?
Teacher 3.
Yes, it would be 3 because this has been differentiated 3 times. Is there any other higher power? If there was d5 in this equation, then we have to take 5, the maximum one. So here order is 1, here order is 3. But out of this, Obviously, the highest one you have to take. Maximum number of times must have been differential. So here, that's why order is 3. And now degree, degree is power, power of highest order. What is the power of this given? This is not given. Just put this as square. What is the power? What is the power of this?
2.
Power is 2. So degree is power of this. So therefore, degree is 2. Even though there is 3 here power, but this 3 power is of what? This fellow. We cannot take 3 as my degree. Don't look for the highest power. Huh? For order, you have to look where which is the highest derivative. But now, what is degree? Power of the highest order derivative. The highest order derivative, you know, is the this. What is its power? Is this. Even though it was 1, degree would have been 1. You cannot take this. Only power of the highest order derivative. So degree will be 2. Because this is the highest order derivative in this whole equation. Anyone who has not understood can ask. You know, we'll solve questions based on this. Before that, I'll just give you what is linear type and non-linear. Classification of differential equation. First type is linear differential equation. Differential equation with degree 1. Now you know what is the degree. So if the equation has degree 1, in the previous example degree was 2, then it is not falling in under linear category. Only if the degree of the equation is 1, then it is called as a differential equation. Example, we'll see what is the order. Order is 1, because maximum times it what is there is dy by dx, only one time, and degree is 1. So our aim is this. So degree is 1 means it is a linear equation. This is the second example. Now don't say this power is 2. So it's not a linear. This power it is not. What the order is 2. Yeah, order is 2. But what is the power? Power is 1. So degree is 1. What is the definition of degree? It's nothing but the power of the highest order derivative. So this is the highest order in this equation. What is its power? 1. So we don't care whether order is 3, 5, 8, doesn't matter. This could have been 8 also. We don't care. What matters is the degree. So degree is 1. So it is linear. Any doubts in this? You can ask. The moment degree of a differential equation is 1, it is called a linear differential equation. Second one, non-linear type. So non-linear, there are two conditions. First thing is degree is more than 1. If degree is more than 1, it falls under non-linear type. In the second one, product containing dependent variable and differential coefficients are present. I'll give you example and then explain this point. First example, I want to check whether this is linear or non-linear type. Now for this equation, can someone tell me what is the order? What is the order of this differential equation?
Teacher 2.
Yes. And what will be the degree?
Teacher 3.
Yes. So,
3.
yes, degree order is 2. The highest time it has been differentiated. How many times taken the derivative? 2 times. And this is straight away the power of this one. This, even though this 4 is more than 3, we don't have to take this because this is the power of a smaller order. We cannot take this. We have to degree is 3. More than 1, therefore non-linear. Degree is more than 1, so it falls under non-linear type. Second one, if you see this x and y are multiplied to each other, there's a product. Here also see, there's a product. So whenever there are product containing dependent variables and some differential coefficients are present, okay, these are like the coefficients present here. So this is a product and differential coefficient is present. That is non-linear type. Even though degree is 1, but there's a product which involves x and y, non-linear type. Question is determine the order and degree of the following differential equations. Also state if it is a linear type or non-linear type. Okay, all this sin x, cos x, the such terms can be there. As long as there is no product, you don't have to worry. Now, what is the order? Order of this will be, it is differentiated one time. The order is 1. What will be the degree? What is going to be the degree? Yeah, degree also will be 1. A linear type, oh, because degree is 1, it is linear type. Second one, Arya, what is the order and the degree? What is the order and degree for the equation? Arya, you're there?
Yes, ma'am. Ma'am, actually, I didn't attend the previous classes because I was ill these days, so I don't know.
Wait,
I
wait, wait. Today is a new chapter. There's nothing related to previous one. Today is a new chapter. It has nothing to do with that. Nothing. Right now, what I'm teaching has to do nothing. I've not even reached the problems which will need the previous chapters. I'm just asking you what is the order. Now, whatever I had explained, the definition and degree based on that. So what is the order and degree? Can anyone else answer?
Ma'am, order is 2 and degree is 1.
Yes, order will be 2 because it is differentiated 2 times, and degree will be because the power is 1. Third one, a linear type this will be because degree is 1. Third one, d square y upon dx square equals to 5. Shweta, welcome to the online class. Now tell me what is the order and the degree?
Ma'am, order is 2 and degree is 3.
Yeah. You have attended no previous classes? Have seen, gone through the recording?
Yes, ma'am.
Okay. So order is 2, degree will be 3. And it will be now non-linear type. Next one. Determine order and degree. First one, dx square. What is going to be the order and the degree? What is going to be the order here in the degree? Anyone can answer.
Teacher, order will be 2,
Yeah, order is 2,
degree is 4.
degree is 4. If in case it was asked linear type, non-linear type, it is non-linear type. Because there are two things. Obviously, degree is also more than 1, and this also there's a product. Actually, it belongs to non-linear type. Next one. These I found on some question paper. I'm just solving those. This is 5. Huh? So as per that, order is 5 and degree is 1. Third one, d square y upon dx square plus sine dy by dx is equal to 5. Again, now this is a special case. Now you just see the definition of a differential equation, or even if you want to say when you want to find a degree. Okay, order anyways will be 2. Okay, now degree, there's a definition. If you go back and check, degree definition says that it is the power of the highest order derivative provided the differential equation is free from any radical. Okay, or any other fractions. So radicals means either root sign or it should be free. Now what is happening? This dy by dx is inside the sign. If it was simply like this, sin x plus this, then you could write the degree. But now this differential equation, it is this dy by dx is not free. Even though this power is free, but the whole differential equation, there should not be any radicals, no fractions, nothing involved in. Now this is something is not free out of this. So this is inside. Now you might say order is 2, but the power is 1. No. Even though this fellow is free, overall you have to check. So here what you have to write is not defined, because dy by dx is not free. It is trapped inside sine function. Dy by dx is not free because this is locked inside sine function. If it was not inside, then you could write the degree as 1. Okay, so differential equation is not free overall. So that time we cannot write the degree. You have to write it as not defined. Same way. Here also same thing. Order is 1, but degree will be not defined because dy by dx is inside a log function. You don't have to write this reason for exam. This is only for your understanding. Only this is needed. Dy by dx is trapped inside log function. Therefore, differential equation is not free. That's why degree is not defined. Next one. Again, dy by dx is raised to some power. There should not be any like this type also. It should be normal, separate dy by dx. Now this is again this one's power, it is trapped with x raised to something. So again, order is 1, but degree is not defined. Hope you all are understanding. If any doubts, then I'll ask her. Next one. No, don't directly go and write order is this is equal to order is 3 and degree not defined. Don't write straight away. First check whether it is possible to remove out or not. It should not be, it should be free from any fractions. Means this is raised to half. Root means raised to half. It should always be free from any fraction. So what I'll do is first try to get rid of the fraction if it is possible. So what I'll do, I'll just square it on both the sides. So root and this will go. So what answer we'll get is, now if you see, it is free from any root. Radical means root. Now it is, there's no root sign, it's a normal differential equation. Now you have to write the order and the degree. The order is 3 and degree will be power of this 2. Next question. Is a cube root. So cube root means how to get rid of this. You can cube on both sides. Cube root and cube will cancel. Now over here both are dy by dx. So order is 1. Now both have the same thing. Now compare. Now you can compare. This is also same order. This is also same. Now among this, which will be the highest order? Means the highest power. Degree can be 3 or 2, but highest you have to consider now. Because this is same. Order is same for both. If this was square, then straight away you have to write 2. But now both are same. So among these two, then 3 is higher. Next one. One side is a cube root, other side there is fourth root of it. Now this cube can also be written as what? 1 plus dy by dx, the whole thing raised to 1 by 3. Same way d square y upon dx square raised to 1 by 4. Now I have to choose a power. There are two different powers. If both the sides it was cube root, we could just cube it on both the sides, it would cancel. Now this side there is 3, this side there is 4 power. Now we have to select a power in such a way which should cancel out with both of them. Or what else you can do is, you can just exchange them also. Later I show you the shortcut, but I want to multiply with some power on both the sides which should cancel. So we just take LCM of 3 and 4, which is the common number which can go with 3 and 4. So we know that 3 into 4, the LCM is 12. So we are going to multiply both the sides power by 12. Now simplify. So 1 plus dy by dx the whole raised to 4. If you want the shortcut, this always power comes up here, this goes up here. You see. So now no need to expand nothing. Even if you expand, no, what is going to happen? You know that your first term is going to be a plus b the whole square. Whenever you have a plus b the whole square, if you expand, you know what is the highest power in this? Obviously, it will be square only. 2. Can, when if you try to expand a plus b the whole cube, you know the highest power in the whole this equation after simplifying is 3 only. It will never, this expansion will power will never go more than the power which is there overall. So you know that even if you expand, the highest power will anyways remain as 4 only here. And even if you expand this, the highest power will remain as 3 only. So no wasting time in expanding and checking. So you know that order is how much? 2. The power, if you expand this, maybe a plus b the whole cube, we will get like this. A cube minus 3a square b plus 3ab square plus b cube or minus b cube. So you know that finally power will remain the highest as 3 only. It will never become 4. So degree will be 3. This is order and this is a degree. Next one. Now there's a fraction raised to some fraction. So we have to try to get rid of that fraction 3 by 2. So what I'm going to do is, I want, when I can get rid of the fraction, what is a fraction? Whenever some number is divided by another number, I want to get rid of this 2. So what I'll do is square on both the sides. Means basically multiply by power 2 on both the sides. If this was 5, we have to multiply both the sides by 5. So now it is square, means upon 2, so I'll just square it on both the sides. Just multiply by power 2. If I'm powering this with 2, multiplying, other side also have to do the same. It basically looks like this, and then 2 and 2 cancels out. Now it is free from any fraction. Power can be there, but it should be only free from a fraction. A fraction is gone. Now can anyone tell me what is the order and the degree?
Teacher, order is 2.
And degree?
Teacher, 2.
Yeah. So order is 2, degree is also.
Excuse me, teacher. Teacher, after squaring that x square will go.
Check where is it? Oh no,
Teacher, on
but
the right.
no. No, over here directly I cannot square, because if I square it will become a plus b the c, a plus b plus c the whole square. Basically I want to get rid of this. So what I can do in this problem is, if I directly square it, it will get complicated. So I'll keep this term this side only and take the remaining terms on the other side. Now you square. Minus I'll take out common and then square. Now root and square will cancel. Minus anyway square will give you plus square. Order is 2, degree is 1. If this was suppose cube, then order would be 3 and degree would be 2. So this was 3 both the places, then order would have been 3 and degree would have been 2. Next one. There's a, this is there in the denominator. So I'll try to get rid of this, any fraction. I'll cross multiply here. If nothing is there, it means there's a power 1. This is the differential equation given. Now just multiply, cross multiply here. Three upon now you can take this term on the other side. And this 1 plus 2 will give me power 3. Winston, what will be the order here?
One,
And degree?
3.
Yes, good. So order will be 1, degree will be, because among these two, the highest is 3. Last one. So now it is not in the proper dy by dx form. Dx is separate and dy is separate. What I'll do is I try to get it in the normal dy by dx form. This I'll bring down. Minus I multiply dy dx. I'll take this side. Okay, this falls under differential equations. Okay, the fraction, radicals, what I talk about should not be there for these things. For the derivatives, as long as this is free out of root and all, doesn't matter. Even though now it is all like this upon this, at least dy by dx is not there in this. If suppose dy by dx was here, then we have to simplify it. Okay, we have to make sure it is in a normal form. Dy by dx is anyway free from any root sign. It is not under any log sign, root sign, nothing. Okay, it is free. Now even though here this is a fraction, that fraction doesn't matter. Fraction, if it was something like this, those fractions matter. Or if it was 1 upon dy by dx. So now here, this, because these are simple x and y terms, there is no derivative involved here. So order will be 1, degree will be 1.
Excuse me, teacher.
Yeah.
Teacher, could you please explain this sum to me again?
See, this dy by dx is there. We don't have to simplify, because as long as there is no dy by dx here, this could be any complicated thing. As long as there's no root sign. In the previous problems, you can go back and check. This was under either root sign or under fractions, or it was in the denominator. But now this is free. Now these are simple x and y terms. So that doesn't matter even if it is in the form of numerator upon denominator, the fraction form. You don't have to worry as long as this is not under fraction or not under root. So straight away you don't have to simplify it more. Here we have to simplify because dx was separate, dy was separate. I brought it in dy by dx form, and these are simple x and y terms. So order will be straight away 1, degree is 1. Understood?
Yes, teacher.
Okay, so this was all about finding order and the degree. Now the next is the types of how to solve solutions of differential equation. There was a topic called as formation of differential equations. That topic has been deleted. That will not be done anyways for you all. Now there are 3 types of solutions. First one is variable separable method. Or they fall under 3 different categories, you can say. Variable separable. Okay. Second one is homogeneous. The third one is linear type. On the this, what is that deleted portion, it says linear type is not there, but I don't know, the teachers are doing that. I've seen one question in the preparatories also. In the papers I cannot predict now, last year it had not come, but I don't know why the teachers are doing that. As well as then the preparatory, maybe there's a confusion that it doesn't fall under linear type, but actually as per the clear CBSE it should have been deleted. But I've asked many colleges, they follow that. So obviously I will solve, because I don't want to take that risk. If it comes for board exam, it would be straight away the 3 or 4 marks then, that problem. So we'll do all the 3 types, not to take a risk. The first one, we follow variable separable method. Okay, the solutions means you have to solve and get back. See, whenever you are given any equation, okay, suppose y square plus 2x plus 5 is equals to 0, then maybe you differentiate and you get the answer is 2y dy by dx plus 2. So this is called a differential equation. After differentiating, what you get. Now what we are going to do is, they will give us a differential equation. We have to find a solution and solve it back to your general normal equation, which was maybe before differentiating what was there. Ulta we have to go now. Okay, that's why it is called solutions. So the question which will come as, it will be just saying as solve. Solve means find a solution. Or we also might say find the solution for differential equation. Mostly they say solve. So first category is variable separable method. Or before that also I'll tell you, there are 2 types of solution, and we divided into 2 categories. One is the general solution and the other one is particular solution.